To this lesson on 4.4 linear inequalities in two variables. We're going to try to answer the essential question of how can the graph of a linear inequality in two variables be used to identify the solutions of the inequality. By the end of this video, you will be able to graph solutions to linear inequalities in two variables. Linear inequalities. We're going to graph the line using slope-intercept form. So that's in the format y equals mx plus b. We should be familiar with that. A solid line, we're going to have our line underneath. So you see the line underneath here, that will indicate when we have a solid line in a graph. And a dashed line will not have that line underneath indicating that it could be equal on the line. The shading. You can pick any XY point on either side of the line to test. 0, 0 can be the easiest point to calculate. We'll get into that more. Feel free to pause the video at any point to catch up on your notes. When you pick a point and you get a true statement, you're going to shade the same side as the point that you picked. When it's false, you would shade on the opposite side. We'll get into an example here. It says to graph the inequality y is less than or equal to x minus 1. Let's first pick out the slope. M is 1 over 1. Remember, if there's no number in front, we can assume 1 over 1. The y-intercept is negative 1. So we can plot our first point on the y-axis at negative 1. And now we need to travel up 1 and over 1 for our next point. And we continue to repeat that up 1 over 1 until we run out of room on the right. And we can go the opposite, down 1 and to the left 1 to help create our points going to the left. We're going to have a solid line because the line is equal to, could be equal to. That means the solution to this inequality could happen on this line or in the shaded region that we identify. So to shade, we need to pick any point above or below the line. Let's suppose we picked this point for negative 3. We're going to plug it into the inequality. We're going to plug our y value of negative 3 in for y and our x value of 3 in for, or 4 in for the x. So if we plug in negative 3, we plug in the 4, we calculate it out, we get negative 3 is less than or equal to positive 3. That is a true statement. Negative 3 is less than 3. Therefore, we should shade this side. That same side that we picked, 4, 3. Now, I just want to point something out here. Sometimes picking 0, 0 might be the easiest to calculate because you don't have to do a whole lot of calculation. If you were to plug in the point 0, 0 into this, here's what it would look like. We'd have 0 and 0 minus 1. Well, that would just leave us with whatever number is going to be here. So we'd have 0 is less than or equal to negative 1. That is a false statement. So I want you to notice that when we pick a side in the true side, we're going to get a true statement, which is where the shading should be. If we picked a point on the other side, we get a false statement. So we really have a 50-50 shot here of getting our shading correct, and how we confirm is by picking points and plugging them into our inequalities. Let's graph this inequality. Y is greater than x minus 1, so the slope, y-intercept negative 1, so we're going to start there, up 1 over 1. This is the exact same line. The only thing that's different is we need a dashed line because there's no line underneath. We can still do the shading. Let's pick the 0, 0. So we're picking this point 0, 0, and we're plugging in 0 for y and 0 for x. We plug it into the inequality, and we get 0 is greater than negative 1. This is a true statement. So this line needs to be shaded above. So remember, if we get something true, we shade towards that point that we pick, usually 0, 0. If we get something false, we would shade away. Write the inequality represented in the graph. Let's pick out the y-intercept. So if we go to the graph, we're looking for where does it cross the y-axis. Looks like it's right here at -3. From here, we can count our slope. Looks like we go up 1 and over 1. So slope is 1 over 1. So this is what we have so far. We have y. We don't have an equal sign or inequality yet. And we have x minus 3 because our slope is 1 and our y-intercept is -3. We have a solid line, so we know that we have to have that line underneath for either one. We know that 0, 0 is shaded in, which means it's a true statement. So if we were to plug in 0, 0 here, and we just guess which way, right? We put 0, 0 in, and we say, okay, is 0 greater than -3, or is 0 less than or equal to -3? Which one is true? This one is true. 0 is more than -3. Therefore, the inequality that we would pick this symbol to write our inequality. Y is greater than or equal to x minus 3. Moving on to our word problem. The Science Club sells t-shirts and keychains to raise money. How many t-shirts and keychains could they sell to meet or exceed their goal? Remember, you can only sell whole numbers of items. Write an inequality to represent the fundraiser. So $15 for each t-shirt and $5 for each keychain. So if we did 15 times x, we don't know how much. We're going to add in our $5 times y, and we've got $750 is the goal. If you think about it, which side do we want more? Do we want this $750 to be the bigger side, or do we want our sales to be the bigger side? Hopefully you're thinking to yourself, we want to sell more than $750. So this is where the direction our inequality should go. Is 60 shirts and 40 keychains a solution? Well, if we plug in 60 for x and 40 for y, we can calculate that out. We get 1,100. That is more than 750. So yes, 60 shirts and 40 keychains is a solution. How about 10 shirts and 80 keychains? If we plug it in, 15 times 10 plus 5 times 80, we get 150 plus 400, 550 is not more than 750. So no, 10 shirts and 80 keychains would not be a solution.